Welcome back, my dear students and friends. Let's continue with class 12 mathematics chapter 4. Let us start a new chapter, determinants. So in the previous chapters and all, we have already done what are matrices. Now today let's move on to a new chapter, chapter 4. It is a follow-up of matrices, determinants. Let us see what is a determinant actually. Corresponding to each square matrix, to be noted only for a square matrix. Suppose a matrix A is given of order n by n. Then there is associated an expression which is called a determinant of A, which is denoted by determinant of A, or determinant of A is, in other words, it has almost the same meaning as magnitude written as. So in other words, we can also say like magnitude of a matrix, mathematically not speaking, but more generally. So determinant of A will be denoted by this bracket, the straight bracket that we use to identify and to denote determinants. Remember that each determinant has a fixed value and also a unique value for every different matrices, and determinant of a non-zero matrix will never be non-square matrix will never be defined. Now let's see how do we find out the determinant of a matrix. How do we find out the determinant of a matrix of order 1? It's simply the value itself, so no problem with that. As I say, not exactly magnitude, but I would rather say like determinant is a fixed value which is associated to every matrices or a matrix, not exactly magnitude. Then how do we find out the value of a determinant of order 2 by 2? So the value of a determinant of order 2 by 2 will be simply cross multiplication. A11 into this minus A12 into A21 into A12. For example, suppose you have a matrix whose determinant you're finding out, that is, determinant will be denoted by these straight lines. 6 minus 3, so it's 6 into minus 2 minus 7 into minus 3, that is minus 12 into plus 21, so that will be 9. So again I repeat, determinant will not exactly be, in other words, magnitude. I would rather say a fixed value which is associated to every given matrix, only square matrix, sorry. Now next, how do we find out the value of a determinant of order 3 by 3 or more, higher orders? For that we will have to first be accustomed, and we'll have to first see how do we find out two terms, two definitions. One is minor of an element in the determinant of A and cofactor of the element in the determinant of A. The minor of an element an element in a matrix A is defined as the value of the determinant obtained by deleting the ith row and jth column of determinant of A, and it is denoted by M, capital M I J. This will be very clear when we do some examples, and cofactor will be simply denoted by this value, where I and J denotes the ith row and the jth column for which you are trying to solve. Now for example, suppose a matrix A is given to you. And you are supposed to find out the determinant of matrix A. So the brackets will be different. So let's first find out the minors and see how do we find out. So M11 will be, so we have here 9 elements, 1 2 3 4 5 6 7 8 9. That means we will also have 9 minors and 9 cofactors, each respectively for each element. So for this element, its minor will be denoted by M11. That will be determinant of the value obtained by deleting its particular row and column. So determinant of this value, so that will be minus 1 2 5 2. So that will be minus 2 minus 10. We have already seen how do you find out the determinant of order 2 by 2, so minus 2 minus 10, that is minus 12. Similarly, how do we find out for M12? So for M12, that will be this minor of this element, first minor of the element in the first row, second column. So that will be, you will delete its respective row and its respective column, so you will be left with to find out for the determinant of this values 4 2 3 2. So that will be 4 2s are 8 minus 3 2s are 6, so 8 minus 6, that shall be 2. Similarly for M13, and likewise if you continue to find out, I'll not find out in detail for all the values. M13 will be 2 3, M21, M22, M23. So M21 you will find, you can verify by yourself by doing a small practice. M31 shall be minus 4. Let's try to find out for M32 randomly. So M32, that is M32, that is the minor of the element in the third row, second column. So for that, again what we will do, delete its respective row, respective column. So 1 2 4 2, 1 2 4 2, so the 2 1s are 2 minus 4 2s are 8, so that will be 2 minus 8, so that is minus 6. Similarly M33, you will find that it will be 11. So now then cofactors will be simply C11, that is minus 1 whole power 1, ith row, ith column, first row, first column, M11. So that will be minus 1 square. M11 we have calculated minus 12. So minus 1 square is 1 into minus 12. So the value will be minus 12, no changes. Similarly C12, C13. So we can again check. C12 you will get minus 2, C13 you will again have 23, C21 you will be having 16, C22 you will have minus 4, C23 you will have minus 14, C31 you will have minus 4, C32, let's just check. So minus 1, 3 plus 2, ith row, jth column, M32, so minus 1 whole power 5, M32 minus 6, so minus 1 power 5, odd number, minus 1, so minus 1 into minus 6 you will be having plus 6. Similarly C33 it will be 11. So these are the minors and cofactors. So now determinant will be, so what will be determinant? Determinants, once we find out the minors and cofactors, how do we find out the determinant of a 3 by 3 matrix? Determinant, so it is nothing but, determinant will be simply defined as the value of a determinant for higher orders is the sum of the product of elements of a row or column with their corresponding cofactors. That is, in other words, A11 its cofactor plus A12 its cofactor plus A13 its cofactor. So that will be actually A11 C11 plus A12 C12 plus A13 C13. So A1, so you can go for any particular rows and columns. So I have gone for this first row, so that will be 1 into C11. C11's value we have actually calculated minus 12 plus A12. So for us A12 was minus 3. C12 we had calculated minus 2 plus A13 is 2. C13 20 3. So minus 12 plus 6 plus 46, so minus 12 plus 52, that will be 40. So that's how we actually calculate the value of the determinant of a given matrix. But we can also do that directly also. So in the next exercise I will exactly tell you how do we calculate the determinant of the matrix quickly without actually finding out the cofactors and minors in detail. This one was done just to introduce to you what are minors and cofactors, because this will be needed again in exercise 3.4 and 4.3 I guess, and furthermore 4.4 onwards again to find out inverse and adjoint of matrices. So this becomes very important topic. I hope you have learned how to find out the minors and cofactors of this particular exercise.